one, it says describe the transformation relative to the parent function. All right, so we're comparing 4 to the x with this function. Okay, so what does that -2 in the exponent do? It goes right to. Okay, what about that 8 on the outside? What does that do? Okay, does anything happen with the 4? Remember, the number that we're raising to an x is just the base. Now, if there was a number out front of that, then that would be a stretch. So for instance, like on the next one, we see that there's a 3 out front. So that's going to be a stretch of 3. So since it's negative, it's going to be a reflection. Now we have this +1 in the exponent. So which direction is that going to move? Left 1. Everybody see where we get that from? Okay. On your mastery check, though, a lot of them are like the next problems where it gives you a verbal description and it says, hey, write this. Okay. So we're taking, on the next one, we're taking this equation and then we're adding all these features to it. Okay. So we're going to write 0.5 raised to the x. And now we're going to add these things. So horizontally shifted 10 units right. How do we make something 10 units right? -10 in that exponent. How do we make something shift 4 units down? -4. Does everybody see where I'm getting this from? It's like doing the reverse of what we just did. Now it's reflected across the x-axis and it's vertically compressed by a factor of 0.25. So that's going to be -0.25. Everybody okay on that? That's what your mastery check is going to look like. All right, front flip. Okay, on this one, it says, given this function, graph these. Okay, now this graph is kind of janky, so I apologize. But we've got h of x -2. Okay, so we're going to take the function and we're going to subtract 2, right? So we're going to move it down. So we're going to say, take each one of these points and we're going to move it down 2 units. Again, this is kind of hard to see. Those lines are not very good. So when we connect it, it'll look like that. And we're going to have h of x -2. You always want to make sure you label each line, just make your life a little bit easier. On the next one, it's got 3 times h of x. So you're going to take your y values and you're going to multiply them times 3. Okay, so take your original. So our original is 0 right here. 0 times 3 is what? Still 0. Okay. What about 3? 3 times 3 is 9. So that's going to be 9 now. Okay. And then this point right here is going to probably be the same. This point right here, which is 1, we're going to multiply it times 3. So this new equation is going to look like this. And so that's going to be 3 times h of x. Everybody see how I get that? And notice how it's a stretch. So it's pulled up a little bit higher than the others. Okay. The last one says h of x +1. So that means that we're going to take the original and we're going to add 1 to it. Okay. So the original's right here. We're going to add 1 to it. Original's right here. We're going to add 1 to it. Original's right here. We're going to add 1 to it. And so that's going to be h of x +1. Now, on your test, you'll obviously have Desmos, so that will be a little bit easier than all of this junk. Questions? Look at my awesome lines. Look at them, so colorful. All right, go ahead and take a look at 9. It says list out all the transformations. Okay, so list out all the transformations. So what's going on in that one? It's reflecting. We got that negative, so it's reflecting. What else? Left 1. And what else? And up 2. Everybody see where I got those from? Okay. What's the asymptote of this guy? 2. It's that number that's chilling on the outside. So y equals 2. What is the y-intercept of f of x? So you got to pay attention to the function notation. That's talking about the original. What's the y-intercept of that one? So if we plugged in 0, we would get 0, 1. So if I plugged in 0 in here, if I typed in my calculator 5 to the 0 power, that would give me 1. So over here on this one, if I plugged in 0 into this equation, I would get -5 plus 2, which is -3, right? So this is going to have a y-intercept of -3. Okay. On the next one, how can the parent function of f of x equals 4 to the x be transformed so it has a y-intercept of -5? So how do you make this have a y-intercept of -5? How do you have this be a y-intercept of -5? Somebody's going to tell me that it's going to be subtracted, but what are we going to subtract? Minus 5? All right, let's try that one. So if I did 4 to the x minus 5, and I plugged 0 in for this one, that would give me 1 minus 5, which is -4. Does that mean that I have a y-intercept of -5? No. Okay, so what do I need to change this to then? -6. All right, let's try it. 4 to the x minus 6. If I plug in 0, I would get 1 minus 5, which is, I'm sorry, 1 minus 6. Apologize. Which is -5. So this would have to be the function. Okay. 127. Okay. So, yes, we are working on writing the equation for these. We've talked about simple interest. We talked about compound interest. We talked a little about appreciation and depreciation, but we haven't really delved into it. Okay, so it says explore and reason. Cindy is buying a new car and wants to learn how the value of her car will change over time. Did you know when you buy a new car and the moment that you drive it off the lot, it loses 50% of its value immediately? Like you could buy like $100,000 car. The moment that you drive it off the lot, it drops to 50,000.
No.
That. Go ahead.
It's always go down in value.
Okay. He said it's electronic, so it's always going to go down in value, which is true. Same thing happens with like TVs and computers and laptops and that kind of stuff. But cars specifically drop a bunch once you drive it off the lot. Okay. The moment that you sign that paper, it drops. So depreciation means to drop in value. Okay. Appreciation means to like bring somebody up. Depreciation means to go down. One such function is applied to the car who shows a declining value is shown. Describe how the value of the car decreases from year to year. So what's happening from this year to this year? So we will go from 24,000 to 19,440 to 16,560. So what's happening each year? What's happening each year? Okay, but how much? We know we're not subtracting. We know we're dealing with division or multiplication, right? So in order for us to figure out the next year, we're going to take 19,440 and we're going to divide it by 24,000. Somebody tell me what that is.
Could you use the model?
Not really.
Don't have the option?
Okay, it would be 0.81. Okay, if we took 16,560 and we divided it by 19,440, we would get 0.85. Yeah. So it's obviously declining, and it's declining by like 80%, right? Like we got that 0.8. Now it is fluctuating a little bit, so we're going to talk about that in just a second. So what kind of function would this be, and explain the pattern? Well, this would be an exponential. Okay, because, yeah, it would be an exponential because it's having a ratio that it's being multiplied by. So giving your answer to part B, what is needed to find the function that this person is using? What do we need to find? So what do we need to find? Well, we would need to find the ratio. So part C is find the ratio. Okay, so it says the population of Valleytown is 5,000 with an annual increase of 1,000. Can the expected population for Valleytown be modeled with an exponential growth function? Explain. So each year they're increasing by 1,000. Is that an exponential function?
No.
Why?
Because it's added less time rather than actually.
Okay, so this is actually a linear function because we're adding 1,000. Okay, so if it's a consistent amount each year, then it's not going to be exponential. If it was based off of a percentage or ratio or fraction or something, then that would be exponential. What? All right, an amount of $3,000 is invested in a certificate of deposit at an annual interest rate of 8%. What will be the difference after 15 years in the value of the CD if the interest is compounded semi-annually compared with the compounded quarterly? So are we going to use compound interest or simple interest on this one? Compound. Why? Compound because how many times a year are we doing this? Quarterly versus semi-annually. That's what we're comparing. Okay, so on here, we're going to use compound interest. We learned this last week. So we got this formula. Okay, and we're first going to look at when it's semi-annually. How many times a year does it happen if it's semi-annually? 2 times. So we're going to plug in. So we've got 3,000. And then we have 1 plus 0.08. And we're going to divide it by 2. We're going to raise it to the second power and multiply it times 15. Okay. We're going to do the same thing, but we're going to do it for quarterly. Okay, so we're going to take 3,000, multiply it times 1 plus 0.08 divided by 4, and then 4 times 15. Can you plug both of those in your calculators and tell me what you get? All right, so what'd y'all get? The first one, when you plug that in, what'd you get? Okay, so if you were to type this in, you gotta make sure that you're using parentheses, and you have to be sure that you're careful and don't make a mistake. So I got 48,672. Okay. Oh, I'm sorry. Yeah, you're right. See, this is why it's important. Okay, 9,730. Okay. And when you type the other one in, I got 9,843. Which one would you want to have happen? One with more money. So the quarterly. Okay. The more that it's compounded, the more money you make. Okay. All right. On the next one, it says a CD earns 4% annual interest compounded monthly. What is the equivalent interest rate? So yes.
What document do we do for it?
For what?
For to take test retake.
All right, so we're on page 130. What kinds of situations can be modeled by exponential growth or exponential decay? Like what real life scenarios is this dealing with? Anybody know? Huh? So what real life scenarios would deal with exponential growth or exponential decay? Houses, cars, what else? Maybe not clothes. Not clothes. Not food. So house, cars. So this is a morbid one. Body decay. Okay. A lot of chemical functions or like medicine. Medicine deals a lot with exponential decay. Okay. What's the difference between simple and compound interest? What's the difference?
Simple is linear. Compound is exponential. The other way around.
Simple is going to do it once a year. Compound interest is going to impact more than once in a year. Okay, so simple happens once. Compound happens more than 1 year. Okay. Growth factor. This is the part that people mess up on the vocab. Okay, on number 3, it says Latanya says that the growth factor of 100 times 1.25 raised to the x is 25%. What mistake did Latanya make? Here's the difference. Growth rate is a percentage. Growth factor is 1 plus that percentage in decimal form. So she said 25%. That's not the growth factor. The growth factor would be 1.25. So we're gonna pause on this. We'll come back to it tomorrow. I want you to take out your delta math. I want you to pick a unit to complete that delta math. A lot of you are in that 60 range. I can't push you to a 70 if you don't give me anything to work with. Okay?